We're going to look at example 1 for parallel circuits. And in this example, we have 3 resistors connected in parallel. So as with any problem involving circuits, we start with a circuit diagram. I'll label these R1, R2, and R3. This is the battery, so we have a total voltage for the battery, and those 4 pieces of information are given. The questions that are being asked for us to find, we first need to find the total resistance of this circuit. Then we're looking for the total current coming out of the battery. Part C is asking us for the current in each of the resistors. And Part D is asking us for the potential drop across each resistor. So the first thing we need to do is find the total resistance, and since this is a parallel circuit, we can do that by using the equation 1 over R1 plus 1 over R2 plus 1 over R3, and then finding the inverse of that value. So we'll do that here. 1 over 60 ohms plus 1 over 30 ohms plus 1 over 20 ohms. I would suggest that you give this a shot in your calculator to confirm you can actually get the right answer, but the correct answer for that part is 10 ohms. That's the total resistance or the equivalent resistance of this circuit. For the second part of this problem, we need to find the total current, and the total current depends on the total voltage and the total resistance. So V equals IR, Ohm's law, is going to be a key component in all of these problems. If we're trying to find the total current, we divide the total voltage by the total resistance. In this case, that's 90 volts, which was given to us, and the 10 ohms that we just found from part A. That's 9.00 amps. Now for part C, we actually need to know what V1, V2, and V3 are, so it makes more sense in this problem to do part D first. And this is a simple parallel connection. So since we have single resistors on 3 individual loops, then each one of those values, V1, V2, and V3, are all equal to the total. That comes back to the loop rule, where it says the rise across each loop is equal to the fall, or the gain in potential difference is equal to the loss in potential difference. So each one of those values is going to be 90 volts across each loop. And what that allows us to do is solve for part C. If we want to know I1, we need to know V1 and R1. We can't combine total resistances with current ones. All our subscript have to be the same. So V1 was 90, R1 was given to us as 60 ohms. So we divide that out and we get 1.50 amps. And we'll do the same for I2 and I3. I2 will be V2 over R2, which again is 90 volts, this time divided by 30 ohms, which gives us 3.00 amps. And then I3 will be V3 divided by R3, which is 90 volts, divided by 20 ohms, which gives us 4.5 amps. We'll make that 4.50 amps. Now here's a nice self-check that often happens with circuit problems. You can use one of your rules to check your answer. In this case, we know that the junction rule tells us the total current in this circuit should equal I1 plus I2 plus I3. So this is just a quick check. In part B, we found that the total current was 9 amps. Well, if we look at what we just found in part C, we have 1.50 amps plus 3.0 amps plus 4.50 amps, which in fact gives us 9.00 amps, which is a nice little check that we got that part right.